so I'm going to be working on some of the problems from the study guide made by Zach and Emma. Okay, this was one problem that was started going over in my class, and it tells you that you have a report where it states that a woman on average visits the doctor at most 2.6 times a year. So since at most, because like Mr. Burrell said, since it has that form of equality in there, and the only hypothesis that can have a form of equality is the null, so this is going to be your HO. And the H1, it's going to contradict it. So this is saying that it's less than or equal to, so now your H1 is going to say that it's more than. And the reason that you know that you're using this mean right here is because they tell you that you're working with the word average. And once you have this right here, now you're going to determine what type of distribution you're going to be using. So Z or T. So over here, notice how they don't tell you what your population standard deviation is. So they only give you sample statistics. You're only going to get a sample mean and a sample standard deviation from this data set right here. So since you don't know what your population standard deviation is going to be, you're going to be using the T distribution. And now, with the Google Sheets, I would write down my statistics from my data set. So they're going to ask for your statistics, your sample mean, and your sample standard deviation. And after plugging these into the Google Sheets calculator, I found that my mean is 4.3. And that my sample standard deviation is 2.5841. And now that you have your sample statistics, now you can go on to finding the p-value, and I'm going to find this by using GeoGebra. So you just go here, and then again, you're using a z-test because you don't know your population standard deviation, and since the problem had the word average in it, you're going to be using mean. And so you just click on that, and your null hypothesis. So they stated that it was at most 2.6, so the 2.6 is going to go right here. And your hypothesis, it always contradicts the null, so your H1 is going to say that your average is more than 2.6, and that is this tail right here. And now onto your sample statistics. So the Google Sheets told me that my sample mean was 4.3, so 4.3 is going to go right here. Told me that my sample standard deviation was this much too. And now your N, your sample size. And since I have 10 numbers, my sample size is going to be 10. And the Google Sheets can also give you that right there. And so once you put all of those in, it just computes it for you. And so it tells me that my T value is 2.0804, and then it gives me the P value from that. And it tells me that my P value is 0.0336. Now I'm going to compare that with my sigma, and my sigma, my level of significance in the problem, was at the 5% level. And so now I'm going to compare my p-value and my level of significance. So taken from the problem, it told me to use a 5% level of significance. My p-value, which was from GeoGebra, is this. So now I'm going to compare to see which one is larger. So my 3 is less than 5, and so my p-value is less than my alpha. So whenever it's less than, you are going to reject HO. So this means that you are rejecting this. So you're saying that no, it is not at most 2.6. And so when it comes to the interpretation of your p-value, if the mean number of times a woman visits her doctor per year is equal to, and this is where you go back to your null hypothesis and you plug in that population mean into your interpretation. And if another study was done with a new sample of 10 women, then their number of visits, then there would be a blank percent chance. This blank percent chance is going to be your p-value right there. So 0.0336 as a percentage is 3.36, which in other words, you could just simplify to 3%. So there is a 3% chance that their average of total visits for this new sample is going to be greater than, and since you're dealing with a sample, you're going to go back to your sample mean, which is 4.3. And when it comes to your level of significance interpretation, what you need to know about the level of significance, which is your alpha, is that it represents the odds of a type 1 error. And a type 1 error is going to be when you say that your null hypothesis is false, even though it's actually true. So when it's rejected, even when it shouldn't be. So in this case, it would be saying that your null hypothesis, which is saying that it's equal to 2.6. So you plug that in right there. And so type 1 error would be when you reject the null hypothesis that it's equal to 2.6, even though it actually is true. And your levels of significance again represents the odds that this type 1 error can happen, and they're going to give you this in the problem. And reading the problem, it told you that you had a 0.05 level of significance, and so this as a percentage is going to be 5%. And so the 5% is going to go right there. And now number 7 tells you that 26% of all college students volunteer on their own time. And now it wants to know if the percentage of college students who volunteer is larger for receiving financial aid. And so notice that they have that keyword there, larger. So that's going to come in handy when you're constructing your null and your researcher's hypothesis. And since there's a percentage right there, and then they say 119 out of 466, you know that you're dealing with a proportion. And proportions, so now I'm going to find H1, which is my researcher's claim, and that's what they're wanting to test. And it wants to know if the percentage is larger. So larger is also known as the more than symbol, and larger than 0.26. And your HO is always going to have a form of equality, and so I would just leave it like that. And okay, so then this one would just be the more than symbol right there. And now on to deciding what test statistic to use. So since this is a proportion, you are always going to be using Z. And now that you have that, now you can find your sample statistics. And the sample statistics, since you are finding a hypothesis test for a proportion, you're going to be using p-hat right here. And p-hat is going to be characterized as your successes out of your sample size. So they tell you that out of a sample of 446 people, only 119 of them are considered successful, because only 119 of them volunteered their time, and that is what they're looking for right there. And now that I have my X's and my sample size, oh, and then it's telling me that I'm using a 0.01 level of significance, I'm going to plug this into GeoGebra. And like I said, a proportion is always going to be using a Z. And since I'm working with a proportion, not means I'm going to be using this test right here. And now I'm just going to set this p equal to my 0.26. And I find that I had 119 successes out of 446. And I set my researcher's hypothesis as a more than symbol because, again, they said larger. So I'm going to be using this tell right here. And after plugging that in the calculator, I get a p-value of 0.3714. And I'm going to be comparing that with my alpha, which is 0.01. And right off the bat, I can already tell that my p-value is larger than my alpha. And whenever it's larger, I am going to fail to reject my null hypothesis. And by failing to reject, I am saying that, yes, this is true. I am backing up the fact that my proportion seems like it is equal to 0.26. And so there is insufficient evidence that the percentage of financial aid recipients who volunteer more is greater than 0.26 because I concluded that there is sufficient evidence that it is equal to. So since there's sufficient evidence that it's equal to because I failed to reject, there is insufficient evidence to prove that it is greater than because there's already evidence that it is exactly equal to.